Hi everyone, hope everyone is doing well. We are going to do the topic nature of roots. Now, when speaking about nature of roots, we need to understand that roots are x values that you find after solving a quadratic equation. I need to make sure that's clear. So the roots are the x values that you find after solving a quadratic equation. So specifically, when you find x values of a quadratic equation, whether by factorization or otherwise, you are finding the roots of an equation. The standard format of a quadratic equation is this one: ax squared plus bx plus c. Notice that a is the coefficient of x squared, or the number multiplying x squared. B is the coefficient of x, and then c is the constant term. When solving for x, particularly using the quadratic formula, we come up to this particular situation: x is equal to minus b plus or minus root of b squared minus 4ac, all this over 2a. Now, the nature of the roots, and what do we mean by that? When we speak about the nature, the nature of the x values, we are asking ourselves, are the x values equal? Because in a typical quadratic equation, you can get 2 or you get 2 x values. Are they equal? Are they rational? What is their nature? Are they irrational? Are they unequal? So goes the story. So when we speak about the nature of the roots, we're trying to determine in our particular finding of these values of x, if those values are equal, if they're rational, irrational, unequal, and so forth. For us to be able to determine this particular nature of the roots, we use this particular situation, the discriminant, this delta b squared minus 4ac. If you look at it from the quadratic equation, you can see it somewhere here under the square root sign. This discriminant, this b squared minus 4ac, determines the nature of the root. It discriminates to say these ones are real, these ones are rational, these ones are unequal, these ones are non-real, so goes the story. So the value of the discriminant discriminates the nature of the root. So when we start doing the analysis of the questions, we need to be able to come up to finding b squared minus 4ac, noticing that b is the coefficient of x, a, the coefficient of x squared, and c, the constant term. This particular note, the discriminant, will help us to be able to know the very nature of the root. So how then do we discriminate? How then do we differentiate between the roots, and to say finally, these are equal, these are rational? What do we need to look into? All right, let's start off. How do I know that the roots are real and they're equal? Real and equal roots are available if the discriminant of that particular equation is equal to 0. So keep this in mind: real and unequal, available if the discriminant is equal to 0. So you have a situation like this here: discriminant is equal to 0. They are real and unequal. All right, that's beautiful. How else do we discriminate? Well, if they are real but unequal. So you got roots that are real but unequal. The condition is that the discriminant must be greater than 0. In other words, the discriminant under the square root sign when solving for your equation must be positive. It means they are real and unequal. In the exam, they don't give you this particular conditions. You must know for yourself that I'm dealing with the real and unequal, or whatever the case could be in that stance from there on. Then further on, when the roots are non-real or imaginary, in other words, the roots are not available, they are non-real, they are imaginary, it means b squared minus 4ac is less than 0. The square root of the discriminant will be negative. In maths, if you were to put the square root of a negative number, so square root of -2, -4, it's an error. There are no square roots for negative numbers. So the roots are non-real, the roots are imaginary, the roots are not available when the discriminant is less than 0. So the conditions must be kept noted as we go on along. How about if the roots are rational? Remember, part of our roots can be rational. So how do you then know that these are rational? They give you a perfect square. So b squared minus 4ac, the discriminant, will give you a perfect square. That's how you know the roots are rational. So rational roots, they give you a perfect square. How about if it's irrational? They will not give you a perfect square. So rational, perfect square, irrational, they don't give me the perfect square. As we go through the questions, you'll be able to see about what I am talking about. All right, perfect. Now, since this is all about the quadratic equation, the quadratic equation gives rise to the quadratic graph. If it's a quadratic graph, the expectation is that the roots, or it cuts the x-axis at 2 points. It's got 2x values for y values of 0. So in a typical quadratic equation, they could be, should be, would be 2 x-intercepts. And when that happens, it means the roots are real, they're distinct, b squared minus 4ac greater than 0. So you can represent it graphically as well. 2 x-intercepts cuts the x-axis at 2 distinct points. Secondly, if the roots are equal, that means that this particular graph cuts the x-axis only at 1 point. It means b squared minus 4ac is equal to 0. The roots are equal. There's only one x-intercept, which also, so you may know, in this case, doubles up as a turning point. How about if there are no real roots? In other words, there are no x values that correspond to a y value of 0. In other words, the graph does not cut the x-axis. Which particular situation would that be? This one here, notice the graph only cuts the y-axis, is not available on the x-axis, b squared minus 4ac, literally is less than 0. So you can do a graphical representation of all of this. Let's do some practice questions just to make sure that this is clear for all of us. Here's a question here. All these are past exam papers, so let's run through them very quickly. Question then says to us here, show that the roots of this particular equation are real and rational. They are real and rational for all values of k. The key is getting the discriminant. Once I get the discriminant, then I can describe them as real and rational. I'm supposed to show that they are real and they are rational. So this is my equation as it stands. Let me rearrange it. I can write this as 3x squared plus here k plus 2, and then multiplied by x. Then I can take this guy to the other side, becomes minus 1, and then plus k, all this is equal to 0. I've rearranged my equation. I've rearranged it in such a way that I'm able to see my A, my B, and my C. So who is A? A is 3, which is the coefficient of x squared. Who is B? B is x plus 2, which is the coefficient of x. And finally, C is -1 plus k. So let me list down what I see. A, what are you? I am 3. B, in this case, is k plus 2. And finally, C is equal to -1 plus k. So to be able to find the nature of the roots, I need to find the discriminant. I need to find b squared minus 4ac. Let's do some math. B squared. This becomes, in this case, k plus 2 squared, all right, minus 4a is 3 multiplied by negative 1 plus k. Let's do some algebra on this one. We open up the brackets of k plus 2 squared. We will end up with k squared plus 4k right here, and then also plus 4. Then we open further here, minus 4 times 3 times minus 1 plus k. Eventually, I end up at plus 12, because this is negative 4 times 3, plus 12 here, and then also minus 12k. Let me gather the k's, the like terms together. When you do the math, you'll end up at k squared minus, in this case, 8k plus 16. This is the discriminant. I am asked to show that the roots are real and that they are rational. Part of being rational was that they give you a perfect square. And perfect squares are numbers that are greater than 0. They are positive numbers. So if it's rational, it gives me a perfect square. Let me see how I can play around with this. If I was to factorize k squared minus 8k plus 16, I would end up at k minus 4 squared. That's the discriminant. And from there on, you will notice that the discriminant is k minus 4 squared, which in essence is a perfect square. So therefore, I have proved by showing that the discriminant is k minus 4 squared that these particular roots are real and they are rational for all values of k. So therefore, I can conclude that b squared minus 4ac is a perfect square. So I'll write it as perfect square right there. And because it's a perfect square, what is the conclusion? The roots are real and the roots are rational for all values of k. So in essence, what you're simply doing is isolating your a, your b, or c, and also being able to then confirm that the roots are real and rational, and that k minus 4 squared, when you break it down, will always give you a perfect square. That's basically what you do. So whenever there's a squared outside, that's how your perfect square scenario looks like from there. All right, perfect. That's our first question. Let's try something else as well as we're going along. Here's another question. It says, if f of x is 0, if f of x is 0 has roots of this one here, for which values of k will the roots be equal? So if you notice that this looks like a quadratic equation, how you would solve it. Now, inside the square root sign, that's where we usually put b squared minus 4ac. So what is being represented by b squared minus 4ac in this case is your 3 minus 12k squared. So that's my discriminant right there. The question says, for which values of x will the roots be equal? I need to think, when are the roots equal? The roots are equal when the discriminant is equal to 0. In other words, when 3 minus 12k squared is equal to 0. We solve for k. So let's do some maths here. I can maybe divide everything by 3 if I want. That becomes 1 minus 4k squared is equal to 0. Then that means it's 1 is equal to 4k squared. Divide everything by 4. 1 over 4 is equal to k squared. Then eventually, I'm going to square root this one in order to be able to get my k values. So my k value becomes plus or minus a half. So for all the k values of k equal to a half and also k equal to negative half, all the roots will be equal. In other words, when you put the discriminant here, your answer will be 0 when k is either half or when k is negative half. It makes sense, right? Because when it's equal, it means the root of the discriminant will always give you 0. So whatever is in the square root sign in this particular situation is a representation of the discriminant as can be seen. So that's our question. Let's try another one. Let's keep adding some more stuff to all of this. So that's what you have when they are equal. So please, guys, remember, by all means, remember what it means when they are real, when they are rational, when they're equal, when they are non-real. Question. The roots of the equation f of x is equal to 0 are the following. Again, I can see the square root sign, which basically tells me about my discriminant. Determine the values of m for which the roots will be non-real. Determine the values of m for which the roots will be non-real. When roots are non-real, sometimes they use the words imaginary. Then it means the discriminant is less than 0. It means whatever is underneath that particular square root sign, the discriminant is less than 0. In other words, 16 minus 4m, okay, minus m plus 5 in this case will be less than 0. The discriminant is less than 0. We now solve for m. The rest is basically algebra. So we go 16 plus 4m squared minus 20m less than 0. Then we can now group them nicely and put it as we would put a quadratic equation, minus 20m, and then I think this should be plus 16. All this is less than 0. Then we can then divide everything by 4 if you'd like to. That becomes m squared minus 5m, okay, and then plus 4 right there, less than 0. Then I can factorize quickly to get my values of m. I can factorize to get my values of m. Then this is basically like an inequality. So then this becomes m minus 4, and this becomes m minus 1. So your critical values here in this case will be found when m is equal to 4 and also when m is equal to 1. Then if you were to put, remember you're looking for the values of m for which the roots would be non-real. If you were to put this in a number line, you would have something to this effect. So you have something to this effect. And what are your critical values? This is what we do when we do inequalities. There's another way to do it, but this is also good as well. So you got 1 right there. Then you got 4. Then you test your values to see if they work. Inequalities. Then I think this should give you positive this side. This gives you negative. That gives you positive as well. Then eventually, what are you looking for? For less than 0, which is between 1 and 4. Mathematically, 1 is less than m is less than 4. For all values between 1 and 4, the roots are non-real. In other words, if you were to take a value between 1 and 4, like 2 for an example, and you put it here for m, put it there for m, this square root sign, this eventually, this will give you something which is negative, meaning that when you square a negative thing, the roots are non-real. It gives you an error in the calculator. So that's what you have right there on these non-real situations. Let's up it up a bit. Let's go up a bit on these ones. We're doing quite interesting questions here. All right, here's another one. Usually this is the format that they come in, but there's other ways which they do. So as we go through this lesson, we can be able to see what's going on. The roots of a quadratic equation are the following. All right, beautiful. For which values of k are the roots real? Roots are real when the discriminant is greater than or even equal to 0. The roots are real, right? So in this case, this is the discriminant minus k minus 4. So minus k minus 4, this one is not difficult at all, greater than or equal to 0. Then now you got minus k greater than or equal to 4. Now you want to make sure that k is positive, so you divide everything by -1. K becomes less than or equal to minus 4. I need to remind someone, look at this. When you divide by a negative sign, negative number, then the sign of the inequality will change. It was greater than or equal to 0. After dividing by -1, it is less than or equal to 0 in this case. So these are the values of k, which will make sure that my roots are real. For every k value less than or equal to -4, the roots are real. Hope you guys are following. Hope you guys are understanding me as I go along with this. All right, let's try another one. All right, beautiful. Look at this. I'm ready. The roots of a quadratic equation are given by this part. I think now you can spot the discriminant, which is 20 plus 8k. Then it says where k is between -3, -2, all the way up to 3. So the values of k are restricted between -3 as well as up to 3. Perfect. Question says write down the two values of k which will make the roots to be rational. The two values of k which will make the roots to be rational. If the roots are rational, then the discriminant is a perfect square. And by the way, perfect squares examples are numbers such as 4, such as 9, such as 16. I think you're getting the trend. 25, perfect square. 36, perfect square. 49, 64. So goes the story. 81, even 100 is a perfect square. So they want us to find the values of k, which will end up giving us underneath that particular square root sign a rational number or a rational root, a perfect square. Let me think with you. If I was to substitute -3 here, underneath here, I'll have 20, all right, plus 8, okay, then -3 right there, which becomes 20 plus -24. I get a -4. Nope, it cannot work because -4 cannot be a perfect square. So let me play around with the numbers. What if I substitute -2? So let me see this, if it works. Let me see if I'm substituting -2, what happens to my story. So I put k as -2, that becomes -16, and look at what I get, 4. In other words, when k is -2, my roots are rational because I get the number 4 eventually when I substitute into the discriminant, and that is a perfect square. Also, another number, if you were to test it, is actually 2. Think about it. If you were to take 2 right there, let's take 2. Let's see how it goes. I take my 2, that gives me 16. That gives me eventually 36. Guess what? Perfect square. And I answered the question. Write down the two values of k, which will make sure that the roots are rational. -2 for k and 2 as well. Perfect. Then B. Write down one value of k for which the roots will be non-real. Non-real, what does it mean? The discriminant is less than 0. The discriminant is negative. What is underneath the square root sign should be negative. And so which value of k gives me that situation? It's -3. If you remember, I already tested -3. When I tested -3, I ended up getting a value which was, in this case, -3 rather, not 2, -3. I ended up getting a value which was -4, and that's non-real. So you can't have a square root of something negative down there. That becomes non-real, just like that. So those are your answers for B. The answer would be when k is -3. The roots will be non-real. Let's go up a bit. Let's go up a bit. All right, so we're learning quite a lot from here. Okay, I'm ready for my next one there. Maybe let me try this one. I think I prefer this one. It says, for which values of k will the equation have no real roots? Nothing. No real roots, right? Imaginary, no real roots. So let's break it down. X squared plus k minus k is plus x rather, minus k is equal to 0. Identify A is 1. Identify B, coefficient of x, B is 1. Identify C is -k for which values of k? Would the roots be non-real? Non-real, discriminant less than 0, ba squared minus 4ac, which basically is 1 squared minus 4a, which is 1 times c minus k less than 0. So eventually I've got 1, then this becomes, in this case, plus 4k less than 0, then 4k less than -1. So k is less than -1/4. So for all values of k less than -1/4, the roots eventually become non-real. So this is what basically you have to do throughout to be able to get these questions right. So nothing out of the ordinary. You just pick it up from there and you'll be able to see how they go. Let's try another one again. All right. So nature of roots, not difficult to understand, quite straightforward from there on. Prove that the roots of the equation, I see that, are real and unequal for all values of P. They are real, that's true, and they are unequal for all real values of P. Already it has been set in such a way that I can see my A, my B, and my C, but I'd like to identify this with you. A is 1, that's the coefficient of x squared. I want to try B. B, in this case, is 2 minus P. Then I want to try C. C is -3 and minus P, A, B, C. I see that. And what am I supposed to do? Prove that the roots are real and unequal. And what do I need? I need the discriminant. So the discriminant right there. Let me get it first. B squared, which is 2 minus P squared minus 4. A is 1, and then C is -3 minus P. The rest is algebra that you need to break down. When we break down the algebra, what do we get? We end up getting P squared minus 4P, all right, plus 4, I think that's a plus 4, then plus 12, and then plus again 4P. So this is when you do the algebra nicely, of which I think you guys can do that. Then now you've got P squared plus 16. That's the discriminant. What does this tell me? P squared plus 16. Now, the values of P are real. Negative or positive doesn't really matter. They are real values. If you were to put a negative number here, you end up getting something which is positive all the time. Whether you put P as 1 or -1, you're going to get a positive number for P squared. And then this eventually proves that the discriminant, which is P squared plus 16, number 1, is real, greater than 0. There's never a time that you're going to get a negative answer for whatever value of P that you put. Never. Because the moment you put negative number for P, always your answer will end up as positive. So there are definitely real roots. The discriminant is greater than 0, and the roots will definitely also be unequal. So that's how you show it there. P squared plus 16 is an interpretation of the situation from what you can see there on. All right, let me try my probably last question with you and see how it can go from there on. So these roots are real and unequal. I think what you're seeing is the emphasis on finding the discriminant, which for me is key to everything else. Here's a question. Given f of x is equal to this equation, it's a quadratic equation. I can see that it's the equation of a quadratic graph, but in the turning point format. You can easily identify 1 and 5 as your coordinates of the turning points. And then also you're given the graph of g of x, which is basically a straight line graph. The graph of y is equal to 3. Now, let me just talk a bit about this one. If you were to emphasize the idea of drawing the graph, this A is 3, so it would be a positive, a smiling graph. And then the turning point would be right here at 1 and 5 right there. So it's got a lower turning point. The turning point is the lowest value of your graph. Question says, as we begin, is it possible for f of x to be equal to g of x? It says, give a reason for your answer. Is it possible? The answer is no. These graphs cannot intersect. The minimum value of this graph, the minimum value is 5. So these graphs cannot intersect. See, the graph of g of x says y is equal to 3. That's what it says. Y is equal to 3. That's the graph of g of x, y is equal to 3. So if you were to draw it, think about it this way. So this would be the Cartesian plane, maybe something to this effect. So now make sure that you visualize this. And then maybe let me just take this line a bit lower. There you are. Yes. So the graph of y is equal to 3 would probably be somewhere here, right? Just below the lowest point. So y is equal to 3. So these two graphs will never, ever meet. So then, because for f of x to be equal to g of x, the graphs must be equal. So the graphs must intersect, they must be equal, but these ones will never intersect because in this case, the lowest value for your y value is 5. So as to answer that, you would write and say, no, there will be no intersection between the graphs. The minimum value of f of x is 5. So it's impossible that these graphs intersect, so they cannot be equal. I hope you get that right and understand it. Let me try the last one. There. It says determine the values of k for which f of x is equal to g of x plus k has 2 unequal roots. Let me just play around with this. F of x, who are you? I am 3 x minus 1 squared plus 5 is equal to g of x plus k, which is 3 plus k. All right, beautiful. I think we can now play around with some maths here, maybe open up the brackets, maybe identify A, B, C from there on. So when you open up the brackets totally, eventually you're going to have it as 3x squared, and then minus 6x, and then this will be plus 3, and then plus 5 right there. All this is equal to 3 plus k. Please, guys, don't make mistakes when it comes to algebra. First, I had to open this one here, then multiply by 3. Eventually, I get to this point. Then, in essence, I'll end up having 3x squared, all right, minus 6x, all right, in this case. And then I'll have it as plus 5 minus k is equal to 0 after taking this to the other side, transposing it. Then I can identify my A, I can identify my B, I can identify my C. Let me get the discriminant very quickly. B squared minus 6 squared minus 4. And then 4A, that's 3. And then also I've got now 5 minus K right there. Do the maths, I end up with 36 minus 60 plus 12K right there. 12K. So that's the discriminant. We keep going. This becomes eventually 12K minus 24. You want to put it a bit neatly right there. So if the roots are unequal, what does it mean? The discriminant is greater than 0. When does that happen? For which k values? 12K minus 24. In this case, greater than 0. We just solve 24 to the other side. I think you see what I'm doing. 12k, that means k is greater than 2. So for all values of k greater than 2, that means that the roots are unequal, and as you can see. So thank you so much, guys, for joining me on this lesson about nature of roots. Practice will make perfect. So go try more questions, but this gives you the basic background to finding this particular nature of roots. May you have a great day onwards, and God bless you.